So today we're going to learn how to integrate exponential and logarithmic functions. So what is integrating? Integrating is when you go from the derivative. Oh, I messed up on that. It's actually dy over dx back into the regular equation. Okay? So let's start out with the logarithms. You know that x must be greater than 0. So there's two symbols that you'll know when you must integrate. The squiggly s, which I'm not sure what it means, and dx after whatever's right here. So this tells you that you have to turn the derivative back into the original equation. So for logarithms, you know that natural log's derivative is 1 over x. And you know that exponentials, the derivative is the same. So, in order to use this for integrals, you would see something similar to this, for example. This is the derivative of natural log. So because we know that, this will equal natural log x, because of this, plus k. Now there are two different types of integrating. There's definite, which I'll talk about a little bit later, and indefinite. You'll see both of them when it comes to certain instances. Now, let's start with indefinite. Okay? The word in basically means nothing. You don't know yet. You'll know when you have an indefinite equation when you don't have any points, no range available, and it looks like this. It looks something like this. Similar to the problem I showed you in the beginning. There's nothing here on those two things, so you don't need to plug in anything. So when you have an indefinite, you must have a plus k at the end, because you don't know what the points are, and you need to know that. So, what is definite? Definite is when you do have points. Points are given. So it looks something like this. So let's say this is 2, this is 1. This would be A, or no, this is B, and this is A. So you know those 2 points. From here, you know the range. So what do you do with these points? Well, these points go back into the original equation after you take the integration. Okay? So, if you have this, for example, you can do something like this. 2, 1, dx. Okay? So you know that this would be natural log of x. So what you do is natural log of 2 minus natural log of 1. You always take biggest minus the little, and then it will give you your answer. Okay? So what does this mean? Or what can you use integration for? You will see when you need to integrate, when you need to find the area under a curve, when you want to find the original equation, from the derivative given. Okay, and also you'll see something similar to this. So this will be your derivative, and you want to find the original equation. So if you see any of these type of things, that means you're integrating. So let's use an example first. I'm gonna start off an example of, let's see, indefinite. Okay. So this equation will look like this. So we know that natural log equals 1 over x. That get that in your brain. So for this, you know that there's no points given. So you definitely know it's an indefinite. So for the first thing, you need to remember that. You know that the bottom, the x, stays the same. So you know that natural log 2x minus 1. And you know that you must have plus k. But what happens to the 4? Well, you must divide it by 2. So 4 divided by 2 equals 2. And that goes into the front. So this goes back into the x. And whatever 1 is, you put it back. So, and you must always put this after this if it's indefinite. Now let's do a definite one. I'm going to use the same problem, but this time I'm going to add points. So 2, 1, 4 over. Okay. So we know that from the other problem, this stays the same. And we know this would be 2. But what we don't know is what to do with these. Well, we know this is B and we know this is A. So what do? Well, we put in 2 natural log 2, we plug it in, minus 1. That's the first one. And then we do it again with the other number given. So here we get 2.197, and this one we get 0. Most of the time, if you have some decimals, use 3 significant figures. 3 significant figures, which would be 1, 2, 3. I just used 4 for that example. So what do you do from here? Well, you subtract B, just B, from A. You're left with this. What's different about this than the indefinite one? Well, there's no plus k because you're given 2 points. So that was integrating logarithms. Now on to exponentials. So you know that the derivative of ex equals ex, so it stays the same. So when finding the integrals of this, you would keep the exponent the same. No matter what. So there's nothing that changes from here to here. It stays the same. Know that. Even if it's something like 2 plus 5, you keep that. The same rules applies to natural exponential functions when it comes to indefinite and definite integrals. So what I just taught you about the logarithmic integration stays the same, like the definite and indefinite, if points are given or if they're not. So for indefinite, you always put a k at the end. So let's do an example of definite. I'm just going to put t. So you have this, or this is indefinite, I'm sorry. This is e to the 2x minus 1 dx. Remember, this and this show that it's a integration. So we know that e to the x is the same. So we know that e to the 2x minus 1 stays the same. And then we must bring this derivative down, so the derivative of 2x equals 2. We put it down into the front. And then plus k. Now, what if we're given points?
You define. In the integration, you define.
You define.
You divide by 2. So
Yeah.
you multiply by 1/2.
Yeah, you divide by 2 and multiply by 1/2 if you have nothing here. So this should actually be 1/2. So if you have points, same equation, dx. You know that e to the 2x minus 1 stays the same, and you put 1/2. So it looks like the same without the plus k. So now you plug in your problems. So this is 1/2 e to 1 minus 1. So I ran out of room, so I'm going to erase this. So you know that 2e to the 2. I kept that as 2 because it makes it a prettier number. 2e to the 2, 1 minus 1 is 5, 4, 3, 6. So from here, subtract these two, and you should get 34.734. Now this is what you get. You always get a number if you do definite. Now, you know these things, you can use it for calculus. Good job.